I'm doing some work on the chassis now. First up, I checked some of the resistors and was pleasantly surprised at how close they are to the stated values. For example, this power resistor tucked down in here is supposed to be 1.2K. And what do I measure? How about that? 1.197. That's pretty darn close. So actually, so far, they've all been well within tolerance. So I don't think I'm going to need to replace any of them. The capacitors, however, I am replacing. There's an electrolytic here, 47 microfarad at 6 volts. I put in a 47 microfarad at 100 volts. Not that I need to go that high in the voltage rating, but that just happens to be what I have on hand. And now I've gone over to this guy, this 0.1 microfarad. I just unsoldered one leg and I was about to do the other when I noticed that connection has broken loose. So that might have very well have been causing some problems for the previous owner of this tube tester. Okay, I finished the recapping, and now for the fun part. I am going to go through these calibration testing instructions I found online. See info if you do a web search with some of those keywords. I imagine you won't have any trouble finding a copy yourself. Now this is several pages long, and I'm not going to go through every step on this video. It would be several hours long and probably very boring. But any key points as I go through the procedure, I will be sure to video. And since I'm sure we're all curious to see if this thing actually works, I will do the first couple steps for sure on video. The author recommends you get the chassis up on blocks, so that's what I've got here. So you can access points down below as needed while you go through the steps. And the first part is to turn it on and allow it to warm up for 5 minutes. So that's the easy part. I've already turned this on before, so I know nothing bad's going to happen. You see the tubes lighting up down below. So I'll resume recording once those have warmed up. Okay, it's had plenty of time to warm up. I've gone ahead and set the switches to the default settings, 6.3 volts, JR 5347, and so on. First thing I'm going to do is check the line adjust. Do that by pushing P7, and it's a very good sign the meter is responding, and it's gone right up to the line test position there. If it wasn't on the line test, you can change this rheostat here. And there we go. Alright. First test has passed. And now I'm supposed to rotate the English and bias position fully counterclockwise, which I've got, and they are both on 0. That's good. And now shorts test. Connect a 220K resistor between pins 8 and 5 in the octal socket. Set the shorts to position 2, and then a neon lamp should glow. So that'll be a way to see if this bulb is good. Let's see, 220K. Okay, 220K resistor. Pin 5, 1, 2, 3, 4, 5, and 8 is the last pin. Alright, might be hard to see, but the light is indeed lighting up. Alright, I'm going to keep going through these tests. Next up, we're going to be doing some voltage checks. Check the filament with an AC voltmeter, so you go through the ranges, and plate voltage test, and so on. It's all pretty clearly laid out here with the steps you're supposed to go through. I just finished going through the meter bridge balance test, and my results were off a bit. As you rotate the English control through its whole range, the needle's not supposed to move much off of 0, just plus or minus 1 tick. Mine was up about 10 ticks or so. I then went ahead and set it up for the mutual conductance reading test, which involves using a variac through an isolation transformer. You monitor the secondary with an AC voltmeter and use a 10K current limiting resistor. Now, if I set all that up and push this button, I'm supposed to get exactly 2000. I get more like 2200. So with both of those tests being off a bit, that's a good indication that the English control is off a bit. They do have instructions in here about how to disconnect it and clean it, so that's what I'm going to go ahead and do. I'm hoping it's not bad, because the odds of me getting another one, I think that could be an expensive proposition. Now the readings aren't horribly off. I got 2200 instead of 2000, so I'm hoping with a little bit of minor adjustment I can get this thing right in the calibration. I carefully made note of all the connections to the English control and unsoldered the wires. So here it is. It's a dual ganged 150 ohm control. In other words, each one is a 150 ohm potentiometer with a single shaft. So when you rotate one, they're both supposed to track, and that's what seems to be off a bit on this. I'm hoping just a simple cleaning will take care of that, but we'll see. So apparently to clean these, the back one's easy. You can just pop this cover off. I believe the cover's just held on by those two little indents there. Now the top one, you can see where it's soldered on there. So you can either just squirt it in the little holes there and kind of try to drip the deoxide out, or you can go ahead and loosen up that solder joint and pry the back cover off a bit and get in there better. I believe the reason it's soldered like that is to keep these in sync. In other words, when this was originally assembled and calibrated, that's where they decided it would work best. So if the cleaning doesn't do it, what you can do is open up that solder joint and rotate the top one a bit so it tracks better with the lower half. Now, worst case scenario, if I cannot get this working properly, you can get replacements. In fact, there's a guy selling some on eBay right now. They are apparently new old stock military spec controls that are identical to this. He wants $40 a pop for one, but given what I've invested in the tube tester, and I'm hoping this will be my main tube tester for years to come, I suppose it's a reasonable investment to make. Alright, I got the back cover pried off and sprayed it with some deoxit. And I can see now that those two holes on the side aren't really going to let me squirt any cleaner in there, because they're not really holes, they're just sort of indentations. So the cover locks on. You really need to get the cover off to get in there. So I have made registration marks around the housing, and I'm getting ready to heat up this joint, and then I should be able to pop this cover off and clean the top section as well. I finished cleaning and remounted the English control. However, I did not resolder the top section of the ganged potentiometer to the bottom so I can rotate them. The reason I did that is that the calibration was off. Now what I can do is, while watching the meter very carefully, reach underneath and rotate this bottom section until I get the reading right on 2000, and then I will, while not budging it or moving it, solder them together to lock it into that calibration point. So there's the control under there. It's right above the 83 rectifier, and there is enough room, if you're careful, to reach in there and grab that bottom section and give it a little tweak, rotate it. So with the setup right now, let's see what I'm reading. That's under 2000 now. Before it was over 2000, so I'm sure I'm not back to where I originally had the two sections together. If I reach under there, give it a tweak. it again. Almost. One more tweak. Alright, that's pretty darn good right there. So now what I'll do is very carefully, try not to move anything, and get my soldering iron down there and solder those two sections back together. Here's where that solder joint actually is. So you can see that there is room to get a soldering iron down in there with the set assembled. So I just touched up that joint and the two are locked together now, and hopefully it will stay within calibration. Okay, one final calibration check. We got 50 volts AC. Got my test rig set up here, so push the button and alright, right on 2000. I think it's time to finally try testing a tube. Recently I went through my tube stash and pulled out a bunch of new old stock tubes of the type I'll be needing for the predicted televisions I'm going to be working on soon. So how about we test some of those? First up, I'm doing the type 5x8. I located it in the roll chart and discovered it was a two-function tube. It's both a pentode and a triode. I'm doing the pentode section first. So we've got filament on 5, and then EV7986 and so on. The tubes had time to warm up, so we can go ahead and do the shorts test. Just rotate it through its 5 positions. If the light stays on, you've got a short. Flash is no big deal. So we're ready for the test. Now notice here for English they say 81, which I do have it set on. What they mean by English is that you can forget about these numbers down here in the actual micromole value. You just look at the red, replace, and green good. If the needle's over into the good, it's a good tube. So let's push P4, and we're well over into the green. It's a good tube. Now if you do want to know the micromoles, that's what these little orange dots are for the 3000, 6000, and 15,000 micromole range, which is what these 3 scales are. So they say a good tube should be 3000. That's right at the edge of the 3000 range. Let's give that one a try first. So I'm going to get on the orange dot. I believe those are factory calibration marks. And push P4. And right over there at the edge. Now if we do the 6000 range, it should be more or less in the middle. Let's give that a try. And push P4. Not bad. And finally for the 15,000 range, should be down a little above the 2500 mark. Let's see. And push the button. And there we go. Alright, everything seems to be working just fine. I'm going to check another. I recently picked up a bunch of Cardin 484 tubes, the type that would be used in a Spartan Equizone. And I'm going through and testing them first on my old triplet emission tester, and I found one that's pretty darn bad. So let's see how it tests in the Hickok, which I've already set up for this tube type. Go into this socket over here. And as usual, do the shorts test. Now this tube type is so old it's not in my chart, but I did get the settings online, and a good tube should read either English on 60 or 1300 micromoles. I've got it on 61st. Let's see what we get. Alright, cool. One instance where you want a tube to test bad. And for the heck of it, let's do the micromose. And oh yeah. Right, now I'll try to find one that does good on the triplet and see what the Hickok has to say. I found a tube that does good on the triplet. So let's see what the Hickok reads. Okay. Short. And oh, cool. Next thing I'll do is dig up that gassy tube and give it a try. It turns out that the gas test only works for tubes for which you can test mutual transconductance. In other words, triodes and pentodes and so on. For rectifiers, well, all you can do is the rectifier test, which is the P3 button here. So I've configured it for a type 80. I've got my gassy type 80 in here. Let's see what we get. Okay, it's definitely in the red range. I'll test the other side of it. Curious that you use a different setting for each side of the 80. 15 on one side and 20 on the other. Not quite sure why that is. And if we test that side, it's also in the replace zone. However, we do know that this tube will work in a radio. It's probably just not working quite as well as a fresh 80, meaning it's got a bit more loss across the tube. It's not conducting as well as it could be, but it'll keep working for a while, at least I hope. I've popped in a type 80 tube that I know is not gassy and tests better on my other tube testers, so let's see what we get with this guy. Okay, it's definitely in the green. Here's one final test. This is the type 1x2 high voltage rectifier. I pulled this out of an Admiral 20x12 TV that I did a few restoration videos on. That set had no high voltage, and this turned out to be the culprit. And upon closer inspection, you could see internally that the filament had pulled away from its support and shorted up against the side of the plate. So let's see what happens in this tester. Well, I check for shorts. Check that out. That's what that light is supposed to do when you've got a short. Because it's got a short, definitely don't want to push any of these buttons. Okay, that completes the restoration, calibration, and testing. I hope you enjoyed this look at a Hickok 600A dynamic mutual conductance tube tester.